Okay, this question deals with a displacement. All that means is a change in position for a train while it accelerates from this speed, and it took this long to do it, and the acceleration was at a rate of 377 kilometers per hour squared. So again, list what we know. We know the VI is 34.5 kilometers per hour. The time is 2.88 minutes. Now, that's one of the reasons why I get students to list the knowns and unknowns, because it helps them to write out the units, and then should help them to realize, ooh, this is in minutes, this is hours, I'm going to have to do some sort of conversion later. So if you don't write these out, then you may not catch that. Okay, so our acceleration here is at 377 kilometers per hour squared. Okay, so let's deal with this guy here and convert that to hours. So 2.88 minutes to hours. So here's a general conversion here. 2.88 minutes. And I need to multiply that by something to get it to hours. Okay, so it's going to be some value or fraction that we need to multiply by, and I need to cancel out the minutes. So put minutes down below, and I need to convert it to hours. Okay, so in 1 hour, how many minutes are there? Well, there's 60. So I'm going to take this and say time is equal to 2.88 divided by 60, and that's going to give us hours. Okay, now all that will equal 2.88 divided by 60 is 0.048 hours. Okay, so that's the time that we'll use for this problem. All right, so now our displacement here is a new formula, and it would look like this. Delta D, so that's our displacement, a change in position, is equal to VIT plus 1/2 AT squared. Okay, that may look like a big formula and intimidating, but it's really not all that bad, and I'll try to break it down afterwards. But let's just plug in what we've got. We've got our initial velocity here is 34.5 times our time, 0.048 hours, plus 1/2 times 377. I'm running out of space here, so I'm just going to move everything over, help myself out. And so now multiply by t squared, so our time is 0.048 hours. Okay, and probably the most common mistake is forgetting to square this value right here. So forgetting that squared is probably the most common error I see students doing. Okay, so and all that is going to equal our change in position. Okay, so let's do that calculation. So we have let's go here, 34.5 is 1.656, and what are the units on this? Well, look, if we've got kilometers per hour times hours, well, we've got hours, and hours are going to be canceled out, leaving us with kilometers, which is good because that's what we want for a change of position. So we've got 1.656 kilometers, and we're going to add that to this calculation here. So let's do that one. We've got, don't forget the squared, so let's go 0.048. Let's take care of that first. And let's change my view here to scientific. And we go 0.048 squared gives me this number. Multiply that by 377 is this number, and then multiply that by a half is this number here. Okay, now all that's going to be added to my 1.656, but I'm going to write this out. So 434304. And what is the units going to work out to there? Well, here we've got hours that are going to be squared, so that hour squared and this hour squared will cancel out, leaving us with kilometers. So again, perfect. We got kilometers. Kilometers plus kilometers. That'll be our delta D, is our change in position. Okay, so we've got this value still in our calculator, and then we're going to add in the 1.65. is 2.090304. Kilometers. Okay, so we've got this value of kilometers. Again, the question is always, where do I round this? So let's take a look at the significant figures from the question. Here I've got 3 significant figures, here I've got 3 significant figures, and here I've got 3 significant figures. In my answer then, I need 3 significant figures. So you start over here at the left, and I go 1, 2, 3. I need to round it right there. And that's easy. This 0 won't affect that 9 whatsoever, so my delta D is equal to 2.09 kilometers. Now, in what direction did it go? Well, I should take a look here. It was in south. Okay, so we've got the direction of south. Put that in square brackets, and then write a statement. The displacement is 2.09 kilometers south. Okay, so that one's fairly straightforward given this formula. Okay, I'll talk about what this formula means with respect to a velocity time graph in my next video, but it can be easily demonstrated there. Okay.